So for this assignment, we must find the distance from Earth to Proxima Centauri in Wolf 359. In order to do so, I have drawn a model representing the problem using the measurements provided. In particular, L is the length between Earth and New Horizon, measured in light years. R is the variable that we need to find, the distance between Earth and the star. 54.8 is the given azimuth to the New Horizon, and B is the given azimuth to the star. B minus 54.8 is the angle between New Horizon and the star as seen from Earth. F is equal to 180 minus, in parentheses, B minus 54.8 is the supplementary angle. The value of F in this case is also less than 90 degrees. In the diagram, the variable d is how much the angle to the star changes when we switch to the New Horizon point of view. We extended the line from Earth to New Horizon, labeled as z, to create a perpendicular line from the star to that line, labeled y. To begin solving this problem, we first find the variable d by measuring the distance between different positions of the star in the animated GIF, which, in the case of Proxima Centauri, is d is equal to 1 divided by 20 times 1/1900th times 360. Now that we have this right-angled triangle, we can say that tangent of f is equal to y divided by z, because y is the opposite and z is the adjacent. From here, we can change the equation into y is equal to z times tangent of f by multiplying both sides by z. Simultaneously, we can also say that tangent of f minus d is equal to y divided by, in parentheses, L plus z. This equation can be changed to, in parentheses, L plus z times tangent of f minus d is equal to y. Since we previously already found that y is equal to z times tangent of f, we can substitute y in that equation with z times tangent of f, creating the equation L times tangent of f minus d plus z times tangent of f minus d is equal to z times tangent of f. To find z from this equation, we must change it to L times tangent of f minus d is equal to z times, in parentheses, tangent of f minus tangent of f minus d. And this, by dividing both sides by tangent of f minus tangent of fd, we will achieve the result of z is equal to L times tangent of f minus d divided by L times tangent of f minus d divided by in parentheses tangent of f minus tangent of f minus d. We can also make the claim that cosine of f is equal to z divided by r, because z is the adjacent and r is the hypotenuse of the triangle created here. By multiplying both sides by r and dividing both sides by cosine of f, we'll get the equation r is equal to z divided by cosine of f. Since we know what z is equal to, we can make our final equation of r is equal to L times tangent of f minus d divided by, in parentheses, cosine of f times tangent of f minus tangent of f minus d. We can use this equation to solve for the distance to both Proxima Centauri and Wolf 359. To use the formula we just made to calculate the distance to Proxima Centauri, we start with the knowledge that b is equal to 146.6. We also measured that d is equal to 1/20th times 1/1900th times 360. L is already given to us at the start and it does not change. We also know that f is equal to 180 minus, in parentheses, b minus 54.8, and this is equal to 88.2. If we plug these variables into the formula we made earlier, we will receive our final result for the distance to Proxima Centauri, which is 4.4822 light years. We can do the same for Wolf 359. For Wolf 359, b is equal to 154.2. d is equal to 0.55 times 1/20th times 1/1900 times 360. L stays the same, and F changes as a result of B changing. So F becomes 80.6. If we input these numbers into the formula we made, we'll get the distance to Wolf 359, which will be 8.0441 light years. Thank you for listening.